Good day to you children. Welcome back to our mathematics class. Let us start with the review. In the last class, we went through the brief history of mathematics and we studied about Thales, Pythagoras and also Euclid. Since this chapter is based on geometry that is laid down by Euclid, we looked at Euclid's definitions of various geometrical elements like point, plane, surface, etc. And then we looked at the axioms. We now know that axioms are the statements which are considered to be the truth without any kind of proofs. They are assumptions which are known to be true without any proofs. So, similarly, we saw that we learnt about 7 different axioms given by Euclid. And the next thing we learnt in the last class was about postulates. Postulates are also just like axioms, but they are for particular field of study. They do not belong to each and they do not agree with each and every scenario, but they agree very well with a particular branch of study like geometry, science, biology, physics, so just like that. In our chapter, we are only considered with the Euclid's postulates which only agree with the field of geometry. So postulates were defined as the statements which are assumed to be the truth without any kind of proof and which belonged to a particular field of study. So the postulates which we learn here are only for the studies of geometry and they do not agree with any other field of study. The next section of our chapter is solved examples which are given in your textbook. So before I move on to the first question, children, please take note how I have divided my page into two parts here. In the right side of my page, I have left some space for rough work. It is necessary whenever you write any test or in your classwork or in your homework, please leave a little bit of space for rough work. Alright, and in the left side, which is the larger portion, I have left it for the solution part and questions part. Okay, so now let us look at the very first question of your textbook example. The first question says that if A, B and C are 3 points on a line and B lies between A and C, then prove that AB plus BC is equal to AC. So these questions were proved are the results. These questions are the results which are proved by Euclid himself. Alright, he applied his axioms and postulates to prove these results here. So let us see how he did it. So in this question, what they are given us first, let us look at what is given. Alright, they have told us that there are 3 points A, B and C lying on a straight line. So first let us draw it. Alright, so this is our straight line. This is our straight line. For a line, there are always arrows at the end. These arrows represents that the line can be extended indefinitely in both directions. So whenever you draw a line, make sure that you have put the arrow marks at the end. Okay, so now what is the question? They have told us that A, B and C are 3 points lying on the line. So this is the point A, this is my point B and this is my point C. So here B lies between A and C. So A and C and B lies in between A and C. So moving ahead, first let us write given. Whenever writing the solution, we have to write given B lies between A and C. Now consider lines AC and AB plus BC. Look at these lines, AC and line AB plus BC. I can write it as AC is equal to AB plus BC. It comes from the fourth axiom of Euclid. It comes from, this is my reason, axiom 4, because here line AC coincides with line AB plus BC. AC is exactly equal to AB plus BC. It superimposes it. So I can write it as AC is equal to AB plus BC. Fourth axiom states that when things coincide with one another, they are equal to one another. So AC is equal to AB plus BC. This is the proof. What we have to prove here? AB plus BC is equal to AC, right? We have to prove that. So it is proved. Hence, proved. This is the solution. In the second question, prove that an equilateral triangle can be constructed on any given line segment. So here we have to prove that an equilateral triangle can be constructed on any given line segment. So first let us draw the line segment here. Let us draw the line segment. So this is our line segment PQ. This is some line segment. So we have to prove that we can construct an equilateral triangle on this line segment. So first let us make use of postulate 3. We have to do some constructions here, so make sure that you have your geometrical box with you. So the first step is to using postulate 3. What does postulate 3 say? Using postulate 3, it says that any circle can be drawn using any center and any radius. Draw circles or arcs. Okay, you can draw a circle or an arc. Both are one and the same. Using postulate 3, draw circles using P and Q as centers. This is our first step. So now we have our line segment PQ. First, I'll take Q to be my center and QP is my radius. Q is my center and QP is my radius. So now I'll draw an arc. I can draw the complete circle here, but I'm just drawing the arc. You can try to draw the complete circle, there is no harm. Now I'll take P to be my center, right? P and Q as centers. First I took Q to be my center. Now I am taking P to be my center with QP as my radius. So now this is the second arc. You can look that both these circles meet at a point up here. Okay, both of these circles meet at the point right there. So now let's join P and Q to this third point R. Let's join them. This is PR and now this is QR. Okay, so this is our triangle. Now all that is left to prove is that we have to prove that all these sides are equal. So second step, I can write that PQ is equal to PR, because when the center was P I took my radius to be q, right? So PQ was my radius here. So now if I consider my center P, then PR is also the radii. So PQ is equal to PR, radii of the circle. Similarly, when Q was the center, QP is equal to QR, QP is equal to QR. Once again, they are radii of the circle. PQ and QP are one and the same. So using axiom 1, what does axiom 1 say? It says that things which are equal to the same things are equal to one another. If AB is equal to BC and BC is equal to CD, then AB is equal to CD. That is the first axiom here. Since PQ is equal to PR and PQ is equal to QR, I can confidently say that PR is equal to QR. So now we have PQ is equal to PR is equal to QR. Therefore, in triangle PQR, all sides are equal. When all sides are equal, that triangle is known as an equilateral triangle. Therefore, triangle PQR is an equilateral triangle. So, what was the question here? We were supposed to prove that from any given line segment, we can draw an equilateral triangle. So, we took the line segment of an unknown length. We didn't measure the length in the beginning here. So, the PQ was the line segment with an unknown length, and using that PQ, we constructed an equilateral triangle and proved that the triangle which we obtained was equilateral using the axioms and postulates given by Euclid. So, hence proved. Let us try to verify by measurements if this is an equilateral triangle. Let us try to verify it. So it is 4.5, PQ is 4.5, QR is 4.5. Similarly, QR and PQ both are 4.5. So it is an equilateral triangle with all sides equal. Now let's move on to exercise 2.1. The first main of the exercise is state true or false. Give reason for your answers. You have to state whether the given statements are true or false, and you have to tell why. If it is true, why? Then if it is false, why? So in the first question of first main, they have told us one line, only one line can pass through a single point. Is it true or false? It is obviously false. It is false, because from the very first postulate, what does the first postulate say? It says that a line can be drawn from one point to another point. From that postulate, we arrived at the axiom which says that infinitely many lines can pass through a given single point. We also looked at an example like the point O, and how infinitely many lines can pass through the given single point O. So if only one line, the statement which is being given to you, only one line can pass through a single point, is false, because we have to write the reason here, because many lines, actually it is infinitely, make it infinitely many lines can pass through a single point. Look at the second statement. There are infinite number of lines which pass through two distinct points. It says that from given two different points, you can draw many number of lines which pass through them at the same time, which is also false, because only one line can pass through such points. If there are 2 points given to you and when you join those 2 points you draw only one line, it is not possible to draw infinitely many lines which will pass through those given points. It will be different if you talk about the individual points, but since we are talking about 2 points at the same time, then there is only one line which can pass through them. Look at the third statement. A terminated line can be produced indefinitely on both sides. It is true, which comes from postulate number 2. It is the true statement. Postulate 2 states that if a line which has been terminated or which has been ended, it can be produced or extended indefinitely on both sides. In the fourth statement, if two circles are equal, then their radii are equal. This statement is also true, which comes from postulate 3. It comes from postulate 3. Postulate 3 says that we can draw any number of circles with any center and any radius. So if two circles are equal, say circle O, circle with center O is equal to circle with center P. Then if those two circles are equal, then they will coincide with each other. If you put them on top of each other, they will perfectly coincide. That means their radius are equal or their radii are equal. In the fifth statement, in the figure, if AB is equal to PQ and PQ is equal to XY, then AB is equal to XY. This is true because of axiom 1, right? Because of axiom 1, which says that things which are equal to the same things are equal to one another. If AB is equal to PQ and PQ is equal to XY, then obviously AB will be equal to XY. In the second main, they have given you several geometrical elements or geometrical objects and they have asked you their definitions. Alright, they have asked you to write the definitions of first parallel lines, second perpendicular lines, third line segment, fourth radius of a circle, and fifth square. But before moving ahead to write their definitions, they have also asked, are there any other terms that need to be defined first? Before you can move to define parallel lines, perpendicular lines, line segment, radius of a circle or a square, are there any other geometrical objects which need definitions here? What are they? You have to write what are those objects which are to be defined before you can move ahead to define these. Just like Euclid did, without defining what a point was, he couldn't define the line. Without defining the lines, he couldn't define the surface. Without defining surfaces, he couldn't define what is a plane surface. So it is important that before you can define any of the geometrical object, we have to look back and see if there are any elements which are to be defined first. All right. So now, before we can move on to define these, what are those different objects and how will you define them? So the solution I will just tell you what are the terms which need to be defined, and it's your job to define them. I will just tell you which terms those are, and it's your job to write their definitions. I will not be giving you the definitions. You have to write the definitions of the terms which are not defined here. Okay, so the terms which are to be defined first are first point, second line, third plane, fourth ray, fifth angle, sixth circle, seventh quadrilateral. So before we move to define parallel lines, perpendicular lines, line segment, radius of a circle and a square, it is necessary that we define what is a point, what is a line, what is a plane, what is a ray, what is an angle, what is a circle, and what is a quadrilateral. After writing the definitions of these 7 geometrical objects, you can proceed to write the definitions of the 5 which have been given to you. So it is your job. Take it as your don't take it as your homework. Just pause the video right now and try to define these 7 geometrical elements, and after that try to write the definitions of these 5 objects which have been given to you in your question. Pause the video and try to solve it right now. Coming to the fourth main, if a point C lies between 2 points such that AC is equal to BC, then prove that AC is equal to half of AB. Explain by drawing the figure. So first let us draw the figure. Okay, here they have given us a line segment AB. They have first given us a line segment AB and told us that C lies between A and B. C lies between A and B such that AC is equal to CB. AC is equal to BC or CB. So C is the midpoint of the line segment AB. It lies in the exact middle of the line segment. So now given AC is equal to BC, this is given to us. We need to prove AC is equal to half BC. Proof. So now let us prove it. So proof. How are we going to prove it? That is the proof. We have AC is equal to BC. This is given. Right? Add AC on both sides of above equation. We get AC plus AC is equal to BC plus AC. This is axiom 2. It says that if equals are added to the equals, AC is equal to AC, right? Which is added to the equals, that is AC is equal to BC. They are equals. If equals are added to the equals, then the wholes, that means the sums, are equal. So now AC plus AC is 2AC which is equal to, look here in the figure, BC plus AC, which is coincided by the line segment AB, which is equal to AB, making use of axiom 4. It says that if things coincide with one another, then they are equal. AB coincides with BC plus AC, so AB will be equal to BC plus AC. Using axiom 4, we get the result 2AC is equal to AB. So now transposing 2 to the other side, AC is equal to half AB. Hence proved. We were supposed to prove AC is equal to half AB and we proved it. Hence proved. Moving on to the fifth main. In question number 4, the point C is called a midpoint of the line segment AB. Prove that every line segment has one and only one midpoint. So in the previous question we saw that there was a point lying on in between A and B on the line segment AB, and we proved that AC is equal to half AB, and we were given that AC is equal to BC. So C was the midpoint of that line segment. In this question we have to show that there is one and only one midpoint for each and every line segment. So to prove that, first let us assume D to be another midpoint. Okay, we knew that C is a midpoint, but now let us assume D to be another midpoint. So from that we get AD is equal to BD, because this will be our line segment like this, AB, and D will be our midpoint. So that will give us AD is equal to BD. This is our first equation. But C is also a midpoint, right? C is also a midpoint. Then AC is equal to BC. This is equation 2. Now subtracting equation 1 from 2. Subtracting equation 1 from 2. So first we'll write equation 2. AC minus AD is equal to BC minus BD. So now AC minus AD will get DC is equal to BC minus BD will once again DC is equal to minus DC. So which implies on transposing, on taking the minus DC to right side, it will become plus. So DC plus DC is equal to 0. This implies 2DC is equal to 0. This implies DC is equal to 0. Therefore, C and D coincide. When two things coincide, then they are equal. C and D coincide. Therefore, point C is equal to D. Therefore, there is only one midpoint. There is only one midpoint to any given line segment. In the sixth question, in the figure given below, if AC is equal to BD, then prove that AB is equal to CD. They have told us the line segment AC is equal to line segment BD. We are supposed to prove AB is equal to CD. So first let us write down given AC is equal to BD. Since AC is equal to BD, I can write them as AB plus BC is equal to BC plus CD. This is from axiom 4, which says if two things coincide with one another, then they are equal. Here line segment AC coincides with AB plus BC. Similarly, BD coincides with BC plus CD. So AC can be written as AB plus AC because they coincide, they are equal. And BD coincides with BC plus CD. So they are equal. So now subtract BC from both sides of given equation. We get AB plus BC minus BC is equal to BC plus CD minus BC using axiom 3. What does axiom 3 say? If equals are subtracted from the equals, then the remainders are equal. So here we talk about subtraction, not the addition. BC minus BC cancels out. BC minus BC cancels out. What is remaining? AB is equal to CD. Hence, proved. That is what we were supposed to prove, right? We were supposed to prove AB is equal to CD, and we got AB is equal to CD. This is the end of your exercise 2.1. Take note of your homework here. In the third main, they have given you 2 postulates, and based on these postulates there are some questions which have been asked, which is for you to answer. And that is the first question. The second question of your homework is to prove that two distinct lines cannot have more than one point in common. This is your second question of the homework. And the third question is the seventh main, that is seventh main from your exercise 2.1. Why is axiom 5 in the Euclid's axioms considered a universal truth? This is not about the postulate, this is about the axiom. The axiom 5 says that whole is always greater than the part. So why is that axiom considered an universal truth? You have to give you the answer with reason. So these 3 questions are your homework. I'll post these questions along with the link to the video. So please solve these questions in your homework book. That is all for today. In the next class, we will discuss about parallel lines and the 5th postulate of Euclid. Thank you.